Hello everyone, my name is Alicia Uline and welcome to my Mathcast. The intended audience is for grade 4 and the learning objective for today is to identify, define, and draw perpendicular lines. Okay, we are going to start off with some math vocabulary that is important to understand before we can identify and draw perpendicular lines successfully. And the first one is going to be right angle. A lot of us are familiar with right angles. They are two rays that are sharing the same endpoint or vertex. So they can be identified easily by these squares here, perfect squares in the corners that are telling us that this is a right angle. A right angle is also identified as an angle with a measure of exactly 90 degrees. This would be best to use a protractor to identify that this is 90 degrees, but given that the squares are already provided in the corners for us, we know that these are 90-degree angles. So for clarification purposes, I'm going to show you a few non-examples, which are going to be our other types of angles, like our acute angles, which look more leaning in, as opposed to what a right angle looks like. They're smaller, much smaller, and they're identified differently. They're identified by a semicircle as opposed to a perfect square. That's going to tell you that this angle is not a right angle. And then also we have obtuse angles, which are opposite than acute angles. They're much more wide open and larger than a right angle, and also are identified by that same kind of semicircle. So you know it's, again, not 90 degrees. Lastly, we're going to talk about a straight angle, which doesn't really have an identifiable symbol like the right angles and the acute and obtuse do, but it's pretty obvious because they are just straight. It's a straight line going on forever in each direction, and it has an angle measurement of 180 degrees. The next vocabulary word that we're going to talk about is intersecting lines. These are lines that share one common point, like you see here. These lines are intersecting, they share this point. These lines are intersecting, sharing this point, and so on and so forth. A non-example of intersecting lines look like this, and these lines are called parallel lines. These can be found in real life, like things such as railroad tracks or rungs on a ladder that take you up the ladder. Those lines are never going to cross each other. That brings us to our final math vocabulary word and our focal point, which is perpendicular lines. Now, these lines do intersect, but at right angles only. As you can see here in the picture, we have our right angle indicator showing us that these two lines are crossing at right angles. You can also identify perpendicular lines in a quadrilateral or any other polygon that have intersecting lines that connect directly at a right angle, 90 degrees. In some non-examples of perpendicular lines we actually saw on the page just before when we were looking at intersecting lines, and they are also intersecting but just not at right angles. And these non-examples are showing us that these intersecting lines, while they do share some qualities that perpendicular lines do, they intersect at a common point, they are not connecting to form 90-degree angles. In fact, they are connecting to create obtuse and acute angles, which tells you that not all intersecting lines are created equal. Now to the fun part. We're going to see if we can identify the set or sets of perpendicular lines that are here in this math drawing. So we know that we have to have intersecting lines, and we know that they have to be forming a right angle. So clearly we can see here, even though it's not already identified, that we have a right angle right there. So that would mean that our intersecting lines are going to be that line and that line to create perpendicular lines. Now, it could not have been our line over here, because those two intersecting lines create something that's much, much smaller than a right angle, which would give us an acute angle on that side. So not intersecting at 90 degrees, meaning not perpendicular lines. Okay, I don't know about you guys, but same thing here, identifying the set or sets of perpendicular lines. I do see many sets of intersecting lines. However, I don't know if they're all perpendicular because I don't see many 90-degree angles. So I'm going to say that we can probably agree that here and here and here and here we have 90-degree angles, which means that our perpendicular lines are here and here. Now let's make sure there's no other ones on this math picture here. Well, really, it's a picture of a kite, but I see a lot of intersecting lines here, here, and here, all the way up that. Those are all acute or obtuse angles. Same thing with these lines intersecting here to that one, acute angle, as well as over here. If we keep analyzing this picture further, we're seeing a lot of repeated angles and shapes here, all of which are not perpendicular lines. So our only set of perpendicular lines are the orange ones here that create 90-degree angles. So looking at this last picture here, we're going to do the same thing. We are going to see multiple sets of perpendicular lines for this picture of a football and the threading on the football. So here you have one line going across, and you have many, 5 actually, perpendicular lines crossing with it that create all 90-degree angles. So here we have found multiple sets. 1, 2, 3, 4, 5 sets of perpendicular lines intersecting and creating 90-degree angles. And that's a wrap. Thank you everyone for watching my math cast on perpendicular lines. Some extra resources I used was basically just the Math Vocabulary Cards application by the Math Learning Center, and I just Googled imaged some of those exit tickets for us today. Again, thanks for coming, and see you next time.